It's good to see everyone here today. My name is Aditya, and I work on observability at Stripe. Now, raise your hand if that word observability means something to you. How many people know what that means? All right, that's like about maybe a third if I'm being generous. That's OK. So in short, my day job is to write open source Go software to help other people know that their services are healthy and operational. But let's unpack that word observability a bit, because it's actually quite relevant to Go programmers. Observability measures how well internal states of a system can be inferred from knowledge of its external outputs. It's a concept from control theory. The dual of observability is controllability, what you actually do with that information to, well, control your systems. And observability is all about gathering and analyzing the data to let you know what decisions to make, what actions are actually going to be relevant for you. And the principles of observability and monitoring might be relevant to all languages, but they're particularly critical for us as Go programmers. Because let's think about it. What is Go used for? Go is used to build things like distributed systems. We've got things like Docker, Kubernetes, Console. It's used to build reliable software where we really care that where uptime is of critical importance. And of course, Go is the language of the cloud. As I think Andy Duran said at the very first GopherCon, Go was the language of the cloud back when we still called the cloud servers. And it's really true. This is what people are using Go for. And so observability is even more critical when we're dealing with distributed systems which have tight reliability guarantees or requirements, and software that runs in the cloud, because we need to make sure that we actually are able to understand its performance and behavior at all points. Now, when it comes to observing Go code, there are three fundamental questions that we might have. What should I observe or monitor? How do I measure and monitor those things in Go? And what does the future of Go observability look like? Since this is a lightning talk, we're going to have time to go into that first question. If you're interested in the answers to the other two, well, this is the research that I do for my day job, thinking about the future of observability in Go. So come talk to me afterwards. Let's start with a pretty simple example. We have a service for Twitter power users. All it's going to do is make a request to to our API, which will then make a request to Twitter's API, get a list of all of that person's followers on Twitter, and then store that in the database, and then return that to the users. Now, we want to make sure that this is distributed, so we'll have multiple copies of our API server, think like multiple different Kubernetes pods that are running. We're using a REST API for this because it's something that's probably common and familiar to most people, but none of this is specific to web services or to HTTP. So how would we know that this service is online? There are many different moving parts to this. What are the things that we would want to monitor? Well, in order to know what to monitor, we need to define our expectations. We need to define our service level agreement, the agreement that we're actually providing to our clients, what we're promising to them. And then we need to define our service level indicators. The indicators are the data that we collect in order to evaluate the SLA that we are promising to our users. So the indicators are what we're measuring to determine whether services are meeting our expectations or our users' expectations, which are actually two different things, but we can think of them together under the SLA, the service level agreement. Now, for every service that you operate, you basically only care about three indicators. And it's very easy to remember because they form the acronym RED. You need to know the rate, the number of requests that are received, the errors, the number of responses that are written, broken down by error status, in this case, the HTTP status, and you care about the duration, which in HTTP lingo means basically your latency. And services can have multiple indicators defined on them at different levels. So we can define a different indicator for the API server from, let's say, our database server, or sorry, our database cluster. And it might be weird to think that every service that we operate will have only these indicators, that these are the only indicators that we care about, but it's actually true, because every single component, if we think about our systems as different layers, our dependencies, we have an entire stack. We have our API server, we have the network, we have the actual hardware. All of these are different components, but we actually still care just about the red metrics at each component. It's a way of comparing apples to apples, how our different aspects of our systems are performing. And so at each level, all we need to do is make sure that we measure our red metrics, and then we have an actual measure of the health of our systems. And so think about the key abstractions that you rely on, whether that's the network, whether that's your hardware, whether that's even the power at your data center. All of those are different aspects which you'll want to define an SLA. What's the SLA for the power availability at your data center? And think about what the minimum inputs you would need to determine whether those abstractions are working. So everything from your database server to the actual CPU, the actual chip that is executing on each of those servers, will have an SLA and will have measurable, ideally measurable, indicator metrics that you can use. And again, those indicator metrics are red. They're the request, the error, and the duration. It's basically how much work is something performing per unit time. How much of that work is it performing correctly, and how long does it actually take to perform that work? Now, typically we consider that there are 3 different aspects of how we get greater visibility into our data. Once we know what our service indicators are, how do we actually figure out what's going wrong and how to debug them? Metrics, logs, and request traces are 3 of those tools that are generally used, and we're not going to have time to go into that today. But I mentioned them here so we get an idea of what the next step looks like. Once you've actually gathered your indicator metrics, what are the next things that you need to look for? But fundamentally, if you take away one thing from this, it's that you need to define and measure your service indicator metrics. Most people, if you talk to most people, they'll have a sense of what it means for their service to be online. But if you actually ask them to codify it, they might hesitate. If you need to hesitate, that means you probably actually haven't defined your indicators, your service level agreement for your clients, and your service level indicators for yourself quite tightly enough. So if you take away one thing from this talk, it's this: define and measure your indicator metrics. Thank you.